Hey y'all. Today's objective is compound interest. So we talked about simple interest. It's money that's earned, and compound interest is also money that is earned or is added to an account, but the interest is added more often, more times. And so I think the best way to introduce compound interest is to show you exactly what it is and compare it to simple interest. So let's just pretend someone has $100 to invest 10% for 5 years. So if it was a simple interest problem, you would just put it into your equation. I equals P times R times T. So $100 principal times 0.10% for 5 years. Now, if you have your calculator handy, you might want to pause and type it in because you'll want to figure out I'll show you in a minute. But 100 times 0.10 times 5. And so the interest is $50 at the end of 5 years. So if you earned $50 at the end of 5 years, you essentially would earn $10 a year. And then the total that this person has after 5 years, the total is $150. That's the total because I added the principal and the interest. Now, if someone is going to have compound interest, what that means is each year the interest is added and then calculated again, and more interest is added and calculated again and again, and I'm going to show you. So we're going to take this and we're going to break it down into year one. All right, so on your paper, write this down. Year one. This person, I don't know if I have a name. Oh, you. Suppose you. Okay. You are going to have $100 at 10%. And instead of putting 5 years, it's just going to be 1 year because it's just the first year. So we don't really need to write times 1. And that means that the interest is $10 because 100 times 10, 1/10 is $10. So that's the interest after 1 year, which is very similar. Over here, we earned $10 each year, and that's where the $50 comes from. The difference is for compound interest, that $10 interest is being added to the principal for year 2. So instead of just $100 for our principal, it's going to be $110 times 10%. See, instead of $100, we're adding these two together, and then we're going to find the interest. So $110 and 10% is $11. So then for year 3, we're going to add that on. So instead of $110, it's actually $121 times 10%. And then you get, I wrote it down over here, you get $12.10. And then for the 4th year, you're going to add those together, and it's $141.10 times 10%. You find the interest, you add that, and then you do it one more year for 5 years. I'm running out of room. And so just trust me that when you do this for 5 years, your total for compound interest is $160.05. So that's your total after 5 years. It's $10 more than over here at simple interest. And so compound interest means it's compounding more than simple interest. Simple interest is you find the interest and it's $10 each year for 5 years. Compound interest changes every year. The balance is different. 100, 110, 121, 141, and 10 cents. And so, actually, yes. Really, this should be 130. Change that. 133. Sorry, I skipped a year. The last one was 140. So compound interest is going to give you more than simple interest because it's compounding more. Now, there is a formula for compound interest. So now that I've shown you what it means, here's the formula. A equals P. So A stands for the amount, and this is your total, not the interest. The total amount. P is principal. 1 plus R. 1 is just one whole. R is your interest rate, and you're going to write it as a decimal. And then to the T power. To the T power, and T is time in years. So for our purposes, for 8th grade math, for our purposes, we're just talking about compounded annually. You can compound monthly, you can compound semi-annually. There's lots you can compound quarterly. But for our introduction to compound interest, we're only going to talk about compounding annually. So make sure you get your formula down. All right, example 1. All right, how much interest will I earn? How much interest will you earn on $600 deposited at 7% compound interest for 2 years? Compounded annually and then for 50 months. So how much interest? So we're actually asking for the interest, which your formula does not give you the interest. The formula gives you the total. So we're going to have to do a step backwards. So we're going to start with our formula. So write your formula, and then we're just going to substitute our numbers in. Our principal is $600, so that's how much we started with. 1 plus our rate is 7%, so 0.07. And then for T years would be 2 years. And if you have your calculator, I encourage you to just type this in. Just like you have it here, just like you see it, 600, 1 plus 0.07 to the second power. And again, I don't know if it might be backwards on yours. So I'm just typing it, whoops. I went ahead and typed in 1.07, but you can also type in 1 plus 0.07. Okay. 1 plus 0.07 to the t, 2 years. And our final answer is $686. $686. Ooh, that marker. And 94 cents. That's our total. But the question's asking for interest. So in order to find the interest, we have to subtract out our initial amount. We have to subtract out our principal. So the interest is $86.94. So that's how you would find the interest when given a compound interest problem. Let me show you how to do for 50 months. Now 50 months is not years. So we're going to actually have the same thing, except instead of putting 2 years, we're going to put 50 out of 12. Because that's how many years you convert 50 months. We divide it by 12 to find out how many years. And then you're going to type it into your calculator. 600 times 1 plus 0.07. And then 50 divided by 12. And so you can type in 50 divided by 12 as an exponent. And when you do that, you get 795, and you might have to round. $795.40. But the interest, remember, we want the interest. We have to subtract out that principal amount. It's going to be $195.40. So that's how you can find the interest for a compound interest problem. Because when you find compound interest, it just gives you the total because each year the interest is being added. All right, example 2. What's the ending balance for an account with $2,455 starting at 3% compounded annually for 6 years? So we're going to start with our formula. And once you practice, you're going to get this formula memorized. We're starting out with $2,455. 1 plus my rate is 3%. And then for 6 years. So this one, whoops, that kind of looks like a 0. And one thing you might get good at is noticing that 1 plus 0.03 is 1.03. So you can start just putting that in once you get used to it. And when you plug this into your calculator, you should get an amount, $2,931.40. So type that into my calculator, and I think you need to round. I think it's going to be 0.38 something, 0.39. But $2,931.40 is your ending balance. So the A stands for amount, your ending amount. All right. Okay, example 3. Matthew borrows $5,000 at a bank, or $5,000 at a 9% rate. If the loan compounds annually, how much will Matt have to pay back in 18 months? And so sometimes when you borrow money, you take out a loan, you have to pay back interest compounded annually. So the longer you have your loan, the more interest you pay. Borrowing money is a bad idea anyways. So we're going to start with our formula. My principal, he borrowed $5,000 and 0.09 is my rate, so I just wrote 1.09 for 18 months, so 18 out of 12. Now, if you know that 18 months is 1.5 years, if you know that 18 months is 1.5 years, you can also put 1.5 there. Either way, when you type in your calculator, it's going to come out to be the same thing. And so if you're not sure how to type this in, I recommend you get your calculator and you type it in to make sure you know. But after 18 months, Matthew is going to have to pay back $5,689.97. So in a year and a half, he had to pay back his $5,000, but he also had to pay back an extra $689.97 in interest in 1.5 years. So that's a lot of interest being paid back, and it's compounded annually. All right, our last example. All right, kind of got smudged. Wesley invests $10,000 for 12 years at a simple interest rate of 6%. So we have Wesley over here, simple interest, I equals PRT. Abe invests $10,000 at a rate of 6% compounded annually for 12 years. So Abe is over here compounding compound interest. So Wesley is doing simple interest, Abe is doing compound interest. Who has more money at the end of 12 years and how much more? Okay, who's going to have more money? It's going to be Abe because he's doing compound interest. But the question is, how much more is he going to have? We have to find the amounts and then subtract them to find out how much more. So Wesley's simple interest will be the easiest. 10,000 at 6% for 12 years. Oops, I put Wes. All right, so at the end of 12 years, Wesley's interest is $7,200, so his total amount is $17,200. Ow, I just got a paper cut. I just got my paper. So Wesley is going to have $17,200 at the end of 12 years just with simple interest. Now, Abe decided to go do compound interest. And so we need to calculate his total. And the nice thing about compound interest is this gives you the total. So $10,000, 6% is 0.06, so 1.06, and 12 years. So type that into your calculator, and when you do, you should get $20,121.96. So that's his total. So obviously he has more. And then the question is, how much more? So we want to make sure we answer both questions. Abe has more. And how much more he has, you would subtract, and Abe has $2,921.96 more than Wesley. All right, so I found that answer because I took simple interest on Wesley, added it together to find his total. I did compound interest with Abe, found his total, and then I subtracted the two. Abe has more by this amount because I subtracted the two. And we're going to practice more with compound interest in class.